this. The majority of developers in the world are JavaScript developers. They're used to having a lot of great tooling and a lot of infrastructure and a lot of documents to keep them within certain guardrails, and they aren't really used to rolling a lot of things on their own. It's not really encouraged within a community where you have a lot of people that are constantly having to work on the same code base. You don't want to constantly learn a new code base every time. You'd want to see the same familiar tooling. Given that it's a decentralized sort of community, there are a few kind of trusted authorities, but they're fragmented. And if you make one mistake in this community, like it's terrible. You can lose millions of dollars, and we've seen this time and time again. And then, as you go through the development process, you will often run into a lot of breaking changes because you didn't pin down your packages, and this happens very, very frequently in this community. There's a lot of alpha and beta software. Whenever we were getting started, we still do contribute to a number of the repositories that we pull in, which is not something that you typically see. Typically, that things are just happening so quickly, you have to help wherever you can. The community, before we had actually getting together developer groups, it was mainly contacting people on GitHub or Gitter, and so not everybody has a community like we have now in Austin to be able to contact each other and ask questions. And again, everything, they're very high stakes. So
just real quick, if you are a developer in Austin, there's a Slack channel, and we do try and help each other out in there. There's also the Gitter channels that Eric mentioned. And just real quick, who here has written any Solidity code? Raise your hand if you've written something in Solidity. All right, so we got a good amount of people here who've done Solidity. That's excellent. Help each other out in the community for sure.
So whenever we were going through building out decentralized applications for enterprise and businesses, we got kind of bummed out a few times with having to build something from the ground up over and over and over again. So we came up with a framework for being able to build atop decentralized applications in a familiar way with familiar tooling to specifically React and React Native developers with an initial focus on React development. We have an event-sourced framework, which means that any action that takes place inside of the application is recorded as a transaction in IPFS, and that is backed up to Ethereum. So that way you can have a transaction log in Ethereum and the actual data stored in IPFS, which is a decentralized data store. And we have a bunch of middleware that enables any sort of state change that occurs in the app to transparently be applied and added to IPFS in that manner. We have tooling to be able to easily rehydrate and cache data, so that way you're not having to ping the blockchain all the time, increasing latency of your decentralized application. And so we leverage existing cloud providers to be able to mitigate some of the problems often faced by decentralized application developers. After establishing that framework, and all this is open source. If you want to check us out on GitHub, Transmute Industries, you'll see it there. We love people that give constructive criticism or just tell us we're wrong. We came up with something known as the Transmute dApp, and that is a Dockerized environment that comes with an IPFS node, an Ethereum node, or test RPC, as well as a web server. And it allows you to get up and running an environment and developing very rapidly, just right off the bat. As long as you have Docker and data virtualization on your machine, you can get started immediately. And a lot of confusion surrounding Ethereum development is actually just setting up your environment. There are a number of components that come into play, and so being able to containerize it was a big step, and being able to allow legitimately JavaScript or React developers to get going on their way and not even really know that they're interacting with the Ethereum blockchain, which is pretty cool. And then the next thing that we built, so we had the framework and we built the dApp, which is built on the framework, is a command line interface. And the command line interface comes with a lot of very useful commands. such as setup, which allows you to set up an environment on your local machine for managing any secrets that you may have for external dependencies or like cloud dependencies such as Firebase or AWS or any place that you need to put secret keys. And then you have init, which will create a new Dockerized decentralized application from a repository that we have, again, which is this is all open source, and we'll use your environment information that was created whenever you ran setup and configured that to be able to automatically be able to hook into any sort of existing services that you have accounts with versus setting that up manually. There's, huh?
It's boilerplate.
It's boilerplate. There's the serve, which allows you to be able to locally run what would be cloud functions. So that way you can do Oracle development. For those of you who aren't familiar, oracles are services that inject data into the blockchain. I mean, you can think of it as like just any API that you have a smart contract that talks to that API and pulls in information and again can send that to another smart contract that's requesting it. And then there's also install deploy, which we're going to talk about a little today. So with the tooling that we have, something that Orie's going to review that he built in a very short period of time, like 24 hours, is a package management system for Ethereum. And so I think it's a really good way to be able to demonstrate the value of event sourcing and the architecture that we've, and an approach that we've taken to being able to build these decentralized applications. So I'm going to hand that over to Orie for that.
Are there no more slides on this? So I'm just going to exit out and look at this stuff.
Yeah.
All right.
No,
All right. So just to sort of summarize what Eric just said, when you want to build an Ethereum application, there aren't frameworks like Meteor or Django or other sort of rich, rapid application development frameworks that you might be used to if you're coming from more traditional cloud software development. And so that's kind of the problem that we're trying to solve. This app right here is a Ethereum-enabled web application, which is hosted in traditional single-page application, so served over HTTPS, DNS, centralized server hosting environment, a connection to a back-end web service, which in this case is Firebase, which allows us to authenticate with a centralized identity provider. But one of the cool things that we've done with our framework is let you log in with Ethereum identities through a transaction signing flow. And so what we're going to show is basically some of this middleware that Eric talked about, like why do you need it? What does it let you do, and how does it speed up application development? So for the purposes of doing this, what we wanted to do was build something brand new in a very short amount of time and sort of talk about why did we architect things this way? Why do we use IPFS? Why do we use event sourcing? And so I'm going to kind of go through this kind of quickly. Unfortunately, this code is in a unstable branch, so it's not checked into our master branch yet, and we'll put a link in the Meetup and in the Slack channel when it sort of stabilizes out. All of what I'm going to show you is going to get merged into our command line interface as a way to deploy applications built with a framework. So this is a sneak peek of a feature that's in progress, but hopefully it'll give you a sense as to what we're trying to accomplish with the framework. And if you have questions, just raise your hand and I'll try and answer them as we go along. So who here is familiar with NPM, Node Package Manager? All right, so you're used to packages already. You know what a package is. Packages, when you have them with NPM, there's NPM and you publish to NPM, and NPM is a centralized package manager, right? So you probably have seen all these security warnings about oh, be careful, don't lose your NPM credentials. Attackers can publish malicious packages and your users will be disrupted and bad things can happen to you. So ask yourself, what would it be like if I could manage my packages myself and I could use the Ethereum blockchain to sort of protect access to those packages? And what if I had some sort of integrity checking built in, which Node Package Manager does have integrity checking built into it, but maybe there's an easier way of building a package manager. And so what we've done with our event source framework and this event store is just create a very, very simple package manager that uses IPFS and an Ethereum smart contract together to create a package index. So if you're checking out this code, I apologize because probably you'll find some bugs because it's very unstable. But basically, there's two components to this demo. There's a command line component, which is going to explain how you're going to publish this package that you're building. And the package could be anything. In this case, it's a create React app application, right? But it could be something more complicated. So the first thing that you're going to want to do is you're going to want to run this create command. And do I have internet? Can I click through this, or is that going to break everything?
See if you have internet. You do.
All right, cool. So let me see. Better? Sorry. Okay. So we're going to look at the command line application interface. And by the way, GitHub's new vulnerability program is great, but if you don't update your package lock, it'll continue to warn you forever. So here, this create command is basically using a bunch of our framework middleware to create a new smart contract, which is going to act as the package manager contract. This package manager contract is going to take new packages, and it's going to add those packages as basically a single event, which has an IPFS hash, which represents your entire published package. And that event is going to get saved to the Ethereum blockchain. And then anyone can look at that smart contract and look through all the IPFS hashes that are published to it, and they can see all of the different package versions. And if you want, you can go to that IPFS hash, and you can download that package just by knowing its IPFS hash. So in order to build this, first you have to create a new smart contract. And in this case, we're using the framework and the factory to do that. So we're creating our new smart contract. And this is deployed from a locally built Solidity file. So probably I've gotten a step ahead of myself right here. For those who are familiar with Solidity development, in this case, our event store here is inheriting from this unsafe event store, where this is why this is in an experimental branch. The unsafe event store is for demoing purposes. It does not protect against write access from arbitrary people. We have a bunch of other event stores that do, and that's why while we're building things quickly, we like to use this, but then we like to add on safer security event stores for things that are gonna be important. But the cool thing to show off here is you can inherit from our Solidity smart contracts that are installed in your node modules. You can compile new smart contracts directly from the contracts that you've installed via our framework. And in this case, we're inheriting from this unsafe event store to create this package manager. And this package manager smart contract basically just has this concept of an event. And those events are what everything is built off of in our system. So going back to this command line interface, after you've created your new smart contract, we just save a JSON representation of what's called a read model to your local file system. And then we reference that read model anytime we want to know the contract address that you're using for development purposes. So what is a read model? In event sourcing, every state change is an event. And if you take all of the events and you apply them one by one with a reducer, if you're familiar with Redux, or other event sourcing patterns like CQRS, like command handlers or event handlers, similar sort of terminology, each of those events builds up a JSON object that represents the state of your smart contract at a moment in time. And what's handy about this framework for developing smart contracts with this, like inheriting from this event store, is that if your smart contract is doing something complicated, you can use the same mechanism for understanding what its current state is that you use in every other smart contract. So there's an event log that shows all the different state transitions that smart contract has gone through. And then you can use the same middleware to ask, what's the current state of my smart contract application? So in the beginning, this read model here is pretty simple. And I wonder if I checked it in. I did. So here it is. It's basically just an address, right? That's it. I'm going to dismiss this for the time being. No, I'm not. I want to leave that open until I fix it. So here's this contract address. That's pretty much the only thing that matters. what you're going to see in a second is like as we publish packages, how does this JSON object change, and how can we sort of use this as a package manager, right? So the next thing that this command line interface lets you do is it lets you publish a package. And in this case, how this all works, it points at the smart contract that's going to represent any published packages, and it's going to add the current directory to IPFS. Now, you'd want to be very careful normally about what is in your directory that you're adding to IPFS, right? Like, imagine that there's secrets or credentials or things in there. You want to be careful about what you publish to IPFS. So just keep that in mind. But in this case right here, we're using the Transmute Framework to, first, we're adding our directory to IPFS. And what we get at the end of that is a series of IPFS hashes that represent all of the content in the directory. And at the top of that is an IPFS hash that represents a folder. And so first we get that IPFS hash that represents those folders. Then we look in package.json and we grab some information from package.json that normally Node Package Manager would care about. And we create a new event, and we save that new event to the event store. And that new event has the package name, the package version, and this IPFS link, which is going to represent the content of that package. And so in just a few lines of code, we've created a way of publishing a package. And if you want to check it out, here it is. It's hosted on IPFS, and these are all of the files that were included. And if you wanted to pull it down or install it, you could run another command that will go and it'll grab, here it is. So in this case, this object here represents a couple different published packages. And you can see we're thinking about the future of our framework. We want to explore ways of bundling up dApps and oracles in a convenient and open source manner that's easy for people to consume or to manage their manage the source or the sort of deployed and public versions of these services. And so we're thinking that in the future you might use the Transmute Framework to build your application, but you also might use pieces of the Transmute Framework to publish that application to your own hosting. So in the case where you're hosting your application, but it's not hosted in the public cloud by Firebase, but it's hosted on IPFS, which means that anyone who has that hash can access your application. So that's sort of the decentralized file hosting, and our framework in general is targeted at a single development experience, but where you can flip the switch. You can say, I want to have centralized hosting, I want to have decentralized hosting. I want to have a centralized Oracle provider with Firebase or Cloud Functions or Amazon Lambda. I want to have a decentralized Oracle provider with Golem, Chainlink, maybe when they're ready, or some of the stuff that we're working on, which hopefully we'll be able to tell you about soon when we're done working on it. But generally speaking, this installation process, the main thing to keep in mind is that it's looking at these IPFS hashes, and it's installing whatever is associated with that IPFS hash. So it really just goes and it grabs those IPFS hashes and it installs them in a directory, and it's just going to give you a copy of your current directory for the purposes of the demo right now. And that's basically it. So, I mean, here's another example of this. There's some other things that we wanted to show off, which are sort of the client-side application development piece of this. So I've just shown you a bunch of Node.js like terminal applications, right? So what happens if you want to use the Transmute framework to build a web application? Well, this is create React app. So let's look at a React component. So here's a React component, and we're inheriting the same Transmute framework object, and we're using that same object to talk to the event store in the exact same way in React. And we're getting this read model, which is that JSON object that we've shown before. And in this case, we're getting it from a contract address. So you can imagine maybe Brennan doesn't like my packages. He deploys his own smart contract because his are better. And I go and I want his packages. I know this contract address, and because he's added no security on his IPFS node, I add that contract address into this application, and I can instantly see all the packages that are saved in there. And then I can I can download them and I can install them if I want just by knowing that contract address, right? So the smart contract as the gatekeeper for packages is kind of the model, and we were able to quickly build this because of the event sourcing nature of the framework and how it all sort of fits together. So that's kind of like a whirlwind tour of all this stuff. I'm not sure how. The reason I'm showing this is this is a very common function. We use this a lot, and this concept of like getting a read model is something that's really, really useful. So in this case, you can see that there's this read model and reducer import at the top. The reducer is a JavaScript object that describes how events transform your read model. And the read model that's imported here is the default one. And so by passing these into this generic Transmute Framework function, you can read all of the events in a smart contract and build up a JSON object in a sort of reliable manner easily. And by using these pieces of the framework, we're able to build this package manager in like 24 hours, basically. And so that's kind of like the high-level takeaway that we wanted to show. The application itself is pretty simple. The one other piece that I've kind of glossed over is this concept of being logged in. And there is code in here to sort of show off pieces of that, but it's kind of tightly coupled to the Transmute framework, and like the way that we're currently kind of tightly coupled to Google Firebase. But in this case, what does it mean to be logged in? In this case, there's a Firebase Cloud function that we talk to, and we play a signature game with that Firebase function to prove that we're controlling an address. And then Firebase will issue a session token for us. This is similar to the way that Uport and Consensus manage some of their JSON web token flows for things like this. And what's cool about sort of having one framework that sort of has one foot in the centralized, JSON web token sessions, traditional cloud computing world, and another foot in decentralized applications, decentralized hosting, smart contracts, decentralized oracles, hopefully in the future, is that you can kind of bridge the gap and you can push things different ways. So maybe you want to have centralized real-time communication with a given address, or you might have a package manager that many people are pushing packages to, and you might see that one of the people who've just pushed a package is currently online because they're logged into Firebase. So you can start to kind of blend the worlds of centralized and decentralized application development, and that's kind of the spirit of the framework and what we're trying to build. We want to make something that's really easy to build complex applications really quickly by being highly opinionated, and then we want to take the pieces of that and sort of spread them out and let you decide what components you need. You need a centralized Oracle service, do you need a decentralized Oracle service? Do you want to host on Azure, do you want to host on Google Cloud? Right now you can only host on Firebase for the centralized version of this. But if you run a decentralized version of it, you can run it all locally, and its main dependencies are IPFS and an Ethereum node. So I think that's, did I forget about anything? So I think that's basically what we wanted to sort of show and talk about. Do you have additional slides? Yeah. All right.
So that was a lot of tech.
Sorry.
And to be able to kind of go backwards a little bit, basically what we've done is we're taking ideas from existing systems. In Ethereum, there is no great package manager. If you're not developer savvy, that's just something that you pull from to be able to get components that you can reuse or functionality that you can reuse in a program so you don't have to rewrite it. There are attempts at being able to make those, but a lot of times I haven't really seen anything come out of that. And we have a system that, when we talk about event sourcing, to bring it down to a very basic level, think about opening up a bank account and putting $20 in, and then putting another $20 and then taking out 10. So the action of opening up a bank account would be an event, so the bank account exists. So would depositing $20, so would depositing $20 once again, and so withdrawing $30. And if you do what Orie's saying and play these events in order, then you start off with a bank account was created, $20 was deposited, $20 was deposited, and then $10 was removed, giving you a bank account with a total of $30. And so at that point in time, you know what the balance is of that bank account, and which is really cool because if you combine this with the properties of Ethereum, which offers you an immutable ledger, which is redundant across millions of nodes, now you can have a source of truth which is inarguable. Like for instance, say that you banked with Wells Fargo and you did a $500 deposit and you check back the next day and it says $200. What can you really do about it? It's their system. Somebody could have tampered with it. And you know you put $500 in, but their system says 200. They're saying 200. But if you have all these millions of nodes which are backing you, it's very hard to debate that. And so we've done, so again, like the whole idea of everything being an event makes this very, very abstract and very, very, you can repurpose it in a number of ways, such as the building of a package manager. So, you know, the idea behind the package manager is deploy things once, use trusted resources. If you don't like them, you can pull them. Again, like you can add security around these things so that way you can restrict who can view the packages. You can have private packages, you can have public packages, and then you can also have version control. And this leads me into the next topic, the next little bit here is that once you have packages, and these packages, they can be smart contracts, they can be widgets, they can be full applications, they can be whatever you want. It's a directory. But the fact is that whatever's in that directory, you can easily consume within yours. So it's effectively a decentralized like NPM to an extent. And that's really great because not only can you publish smart contracts, but you can also publish code which communicates with those smart contracts in the internet. Again, oracles. And a lot of smart contracts, like there's no easy way to be able to communicate with the internet. And given that the majority of our lives are on the internet and the majority of information comes from that, you know, how do you get more information to the blockchain? Certainly, you know, you can input new information such as a contract between two parties, but what if there is information in that, what if there's a constraint in that contract that depends upon, you know, what the weather is a certain day or like who won the World Series? Then you have to start getting that information from an external source. And so with this package management system and this event sourcing architecture of being able to combine centralized and decentralized providers, you can very easily start to bridge the gap between the internet as well as the blockchain, which is a very, very excellent thing to do. And so regarding like kind of what we're going towards is that here's like a use case of the platform that we're currently working on. If you say you're a developer and you have an idea for an oracle, say you want to make a Stripe oracle, that you want to be able to automatically maybe convert Ether into dollars or be able to send Ether to a contract as well as like some information which would relay a US dollar fiat payment to another individual, that you go and you wrap the Stripe API and you have a smart contract that talks to that, and you can put little fees on every function or not on your smart contract. You can either host with us or you can host it on your own. Again, it's all up to you. It'll probably, but the fact is that we're making this platform because we want to make it easier for people. So maybe you host with us until you're like, I'm going to go ahead and go off the rails here and see if I can do it on my own. So you pay an Oracle hosting fee with us. You have a smart Oracle contract as well as like some cloud functions which we're hosting. And some consumer comes along and says, hey, I want to talk to Stripe, but I don't want to build all that out. And so they can go and see what sort of packages are publicly available. They look at the public repository. They see a public Stripe package. They check it out. And they say, I definitely want to use that. Like maybe there's a reputation system around it. Again, like going around with integrity and such. So you can see the interface for that, how to be able to consume it, send gas as well as Oracle fees to be able to pay to reimburse the individual who's paying for it to be hosted, as well as keeping it stable, maintaining it. And so at the end of this, like the individual who deployed it is getting these Oracle fees, and we are doing nothing and getting hosting fees, which is super great. So if you're wondering about viable business, like, they exist in blockchain space. So a little less techy. We're planning on releasing an alpha here in the next 2 months. And what it'll kind of look like is, here's kind of an idea of what we're going after, is that you have a dashboard and you can log in with an Ethereum address, and here's one screen where you can create a decentralized application. So I don't know how well you can, I guess you can see it pretty well. So you can create a dApp, you can see your existing dApps, and there are a few components that you can choose from. You can have centralized or decentralized hosting providers or storage providers. In this case, like, we see that you can choose a centralized hosting provider such as AWS or Azure or Firebase, and then you can also add configs, such as adding secrets into there. And then whenever you pull down this application, we can automatically configure all that within the local application for you. You can select storage providers such as Swarm, IPFS, MadeSafe, or Saya, and be able to choose computation providers such as like Golem, Enigma, or Zenit. And then you can also, as a additional piece, add decentralized services and oracles to your application to automatically pull down and install those deployed packages, which are publicly available or even privately available based upon if your address that you were logged in is whitelisted or not. So I mean, the idea is to take that kind of tech-heavy approach that if you're a developer, you can totally go in and see all of our open source stuff and do what we're talking about. But we're working to make this much more friendly UI for people that are trying to get involved in it, so they have something that works right off the bat, and they don't have to learn a lot about running their own IPFS nodes or running an Ethereum node or setting up any sort of config. We want to make it basically as mindless as possible to get started and lower the barrier to entry. Anything to add to that?
No. That's it.
So if you're a developer, please check out some of our stuff. We're at github.com/transmute-industries. You can also view a live demo at dApp.transmute.industries. It's not .com, it's .industries. That's a valid TLD. Yeah, if anybody has any questions, now would be the time to ask them. If you're lucky, I might have your shirt size. So we've got these baller Transmute V-necks and such.
Yeah. So any questions before we?
So what's the difference between just sending a transaction to a contract?
Right. So there's a couple of different ways that you can build more complex event source systems on the Ethereum blockchain. You can think of Ethereum as an event source system because it is one. And in this case, our events have a record that's in a specific smart contract, and that record has a struct, and that struct has a specific interface. I think I showed it at one point in the slides. And so when you add an event in our system, you're adding a bunch of data to the blockchain to this struct, basically, and you're saving that struct in an index. So event 1 has this struct, event 2 has this struct over here. So every time you save information to the Ethereum blockchain, you have to pay to do that. And so in this case, it's kind of an expensive way of storing that kind of data, but you can save by storing small references like IPFS hashes that might point to larger collections of data off the chain. So the difference between a regular Ethereum transaction and the event, like adding an event in our system, is that there isn't one. It's still a single transaction. It's just that transaction contains some state update to the Ethereum blockchain that's very easy to replay and rebuild and has everything that it needs to integrate into, for smart contracts to extend on top of it. There's a thing called a Solidity event. How many of you have used Solidity events to help your smart contracts see what's going on, right? So if you're familiar with Solidity events, We use those, and we emit a Solidity event that's equivalent to that struct after we save it. The reason we save that struct in addition is because some smart contracts that extend our event store may want to look into there and look at that event and may want to do stuff with that data. And if you just invent a regular Solidity event, you have to do that like outside of the chain. Like you can't get back to those events that are emitted. And so that's why we save that state into the chain. Certain applications you wouldn't need to do that, but by doing that here, we can build this interface that's really robust. And there's computational overhead for providing that flexibility to developers. But we think it's worth it for rapid application development, especially if you're trying to build something out quickly. It's helpful to have that state be in the smart contract.
Just want to ask if you want a shirt, Ryan.
Yeah, give him a shirt. What size?
You're not getting a choice.
What do you got here? Medium.
All right. Well, while he's looking for a shirt, any other questions?
Just kind of curious how you guys are planning on managing the cost of it. Especially high volume events, it's super expensive.
Yeah.
I mean, are you doing some sort of batching serving the rights?
Yeah. So I mean, you have the option of adding a caching layer that we can provide to you, or you can roll on your own. It's integrated into the system automatically that will automatically rehydrate and build these models and save a state. And like Firebase, we're coupled with Firebase pretty closely right now.
So that when you're rebuilding that read model state, you could start at event 0 and rebuild it from scratch every time. And what Eric's saying is like right now we have one caching interface that lives in Firebase, which means that you automatically get a JSON representation of the current state of your smart contract for free. Every time you run that sync read model command, you're saving what's the current state of my smart contract to a document database where you can do relational querying on it and you can do other fancy stuff. If you're not connected to Firebase, we'll do that locally. And so we can use local storage if you want to. There might be security reasons why you might not want to do that. Or if you're running the same thing locally on Node, we can use other local file system stuff to save you from having to rebuild the entire event stream into the read model every time. So let's say that I published a package and I synced, and then like a couple days later, Eric publishes a package. I'm just going to have to look at all the events since the last time I synced. And so we have saved some time by implementing that. Was there another part of that regarding cost?
I'm just curious.
Yeah.
Start doing this stuff that's a little bit more sort of real-time event heavy.
Yeah.
That could be a super expensive process.
Right.
So it's like filling and batching.
Right. Yeah. So regarding like real-time and like high bandwidth communication, we're really interested in like a lot of like the Swarm development in the Ethereum ecosystem. There's some high bandwidth tooling that they've added. And in fact, at DevCon, they demonstrated a live video streaming service, which is really exciting. And we totally want to integrate with Swarm as quickly as possible so that we can offer Swarm and IPFS next to each other. And I think that especially on the sort of cost-saving sides, there's lots of cases where you want to make one transaction to Ethereum rarely and do a lot of verified computation outside of the blockchain, basically, as a solution to the cost problem. Andrew.
What's your Jeff marketplace going live?
When are we going live?
Yeah, the Jeff marketplace.
Well, I don't know. We're still working on it. We're hoping to have. So what did you just announced a date, right?
Yeah,
mid-January. Right. So we're hoping to have a very shaky alpha version of this available mid-January, and the more problems you find with it, the faster it'll get better. So please give it a try when we have something, and I'm happy to work with you if you encounter any troubles with any of the framework stuff. All open source, open an issue, we'll help you. I'm sorry? Oh yeah. Well, sorry. Yeah. So what's your question? Right.
And if you want to deploy new code, that gets a new address, right?
Yeah. So the process of updating Ethereum smart contracts is an amusing problem, right? An immutable ledger, and there have been problems with not being able to update smart contract code, and there have been even worse problems with being able to update smart contract code. So the answer to that is you have to carefully design that system. The contracts that we show and that are part of the framework are highly experimental, but things like the proxy patterns for being able to delegate call through contracts, they open you up to a whole bunch of attacks that are very scary, but they offer the flexibility to be able to update your smart contract if you needed the interface to change. So these event stores are meant to be the base building block. And for many practical applications, you would basically take a full copy of it and make a bunch of changes. The main thing to keep in mind that's the same is the read and the write interfaces. If the read and the write interfaces and the index interface are the same and they're always accessible, then you can use the framework on it no matter what else is happening in the contract. So for more complex cases where you need to be able to update the contract code, you can go do that. We don't have any of those examples just yet, but if you feel like writing one, well, certainly we'd love to add a good example. Oh, okay. Yeah. So in that case, you can't update a package in IPFS. The hash represents a snapshot of a file system at a moment in time. If you want to make a change, you have to publish a new version, just like NPM. In this case, that version number and that hash are kind of, the hash really is the version number in this case, right? And that's kind of how it should always have been. And no one wants to read a hash instead of like a nice version number, but certainly you wouldn't want to install version 2 and have secretly the binaries changed underneath you. And IPFS prevents that from happening. So I guess the answer is like, you can publish a new package version, you get a new hash, and you can ask which version that was published to the contract you want. Any other questions? Yeah.
The work that you're doing in the framework, you mentioned IPFS as
Yep.
the primary storage option as far as where you want to keep data.
Right now.
For now. So is there a plan in the architecture to allow different versions to exist in different storage networks? Because it seems like there's some issues with that. Okay.
Yeah, so the interface that the framework supports for storing data in IPFS is actually fairly small. And so with a small amount of effort, we're going to create an adapter pattern for that where you can plug in Swarm, you can plug in Sire storage or these other tooling to store any system that supports content addressing. So where the directory or the binaries are addressed by hashes, anything that supports that interface is compatible with the framework. But right now we only support IPFS because limited developer workforce, and IPFS works pretty well right now.
And that's great. That makes sense. You mentioned a couple. I didn't know if you mentioned some of the hot ones that are spinning up, like Gennaro, and
Yeah.
There's different things around mainsafe.
Yep.
And things like that. So it's hearing what you're looking at.
Right.
I think it's helpful for us as a community.
Right.
Kind of
So we think of like any of these systems that are content addressed as basically being exchangeable, direct substitute. We should be able to replace Swarm with IPFS or IPFS with Swarm as long as that content addressing feature exists. We can use that decentralized file storage system to host application code or other services or data that are needed. And one thing I didn't mention about the smart contract, imagine that you had published some encrypted packages and you had lost control of the keys that were managing them. And so your IPFS node is out there serving packages that are encrypted with keys that are compromised. And you're really scared, you want to end that. Well, you can go to the smart contract, you can look at all of the hashes, and you can go to your IPFS node, as long as this IPFS node is really the only node that can serve those binaries, and you can just delete all of them. So having this record of like, what am I actually using? What IPFS hashes represent valuable, risky information related to my application? An immutable store of that on the blockchain, and being able to purge potentially corrupted or leaked data is like a feature that we're like really interested in exploring, like the future of. But obviously, like this is like still pretty early, and so we haven't gotten to that just yet. Yeah. Any other? So I'm sorry?
What kind of encryption you use?
Encryption, right. So right now, when we read the chain, so it's important to mention that everything that goes on the Ethereum blockchain is public to everybody. So if you want to encrypt data before you add it to the chain, you can. In these cases, for most of these read models, we don't encrypt the read model outside of the blockchain because it just represents events that are public on the blockchain. So there's no reason to encrypt the read model because it's just a view of publicly available information. But there are cases where you might want to do that for some reason. It's important to remember that everything that you read out of the blockchain, anyone can read out of the blockchain. So you don't get a lot out of encrypting it after you've read it out of the blockchain. But if you encrypt before you add it to the blockchain, and then as you're reading it out, you decrypt it, that might be something that you want to encrypt. And so in those cases, we don't have any sort of, this is an important note. Like this stuff is under heavy development, and it's for proof of concepts and for rapid application development. We don't have built into it a bunch of security mechanisms that you would really want to make sure, that if you had encrypted before you'd save to the blockchain, that you have a reasonable way of managing read models that might contain sensitive information outside. However, there's a number of different approaches that you could have to that. And if you're existing in centralized infrastructure, you can use built-in security for centralized cloud providers to handle some of that for you. Like in the case of Firebase, the access to the read models that are stored in Firebase can actually be protected via their normal session access control sort of paradigm. So in that login example that we showed, you have a session token with an address. You can use that address to grant or revoke access to documents stored in the Firebase document database, which are read models. So that's an example where you're using traditional cloud security to protect information that's being retrieved from the blockchain. Oh yeah. You get so can you
What's your size?
Large.
Okay. Well, we got started a little bit late. Before we close up, this is the Austin Ethereum Meetup. The people in the room are the people who love Ethereum and want to work and build awesome stuff. So take the time to meet people and say hello and ask them what they're working on. We host this meetup twice a month. Austin Ethereum Meetup on meetup.com, and there's a Slack channel if you want to get in touch with any of the developers or people around here. Thanks again to Capital Factory. Thank you.